Let's talk about adding and subtracting expressions with variables in them. So when you're adding or subtracting, things get a little more strict, but we can only add and subtract what are considered like terms, okay? And to be considered like terms, there's two things that need to be met. They have to have the same base, okay? So that would often translate into the variable. And they also have to have the same power or exponent, okay? So if they have the same base and the same power, then we add up how many of those we have. So look at example number 1 here. This one says x plus 3x. Okay, so if we look at this one has a base of x and a power of 1, and this one has a coefficient of 3 with a base x and a power of 1. So if we look at that, those are like terms. They both have the same base. The base is x, and they both have the same power, 1. Okay, the coefficients don't matter. The coefficient, this one has a coefficient of 1, this one has a coefficient of 3. Those don't have to match. It's just the base and the power. If they're the same, you add up how many you have. So right here I have 1x to the first plus 3x to the first. That's going to give me 1 plus 3 is 4x to the first powers. Okay. Take a look at number 2. We have x minus x squared. Again, these ones have a base of x. They're both base x. Okay. But the powers don't match. Since this one is x to the first, and this one's x squared, we actually can't add or subtract those any more than they already are. So this one is actually already simplified. They don't have the same power, which means they're not like terms anymore, so they aren't able to be added or subtracted together. Okay. Look at number 3. We have 9w to the 5th minus 7x to the 5th. Kind of the same thing happens here. I mean, 9w, base is w, 7x, base is x. The bases don't match. So if the bases don't match, you can't add or subtract them together. They have to have the same base and the same power. They do have the same power, but the base doesn't match up. Okay, so that's it. No more subtracting there. If you look at number 4, we'll actually be able to add some of this one together. So we have a 10x squared, so base is x, power is 2, minus 5, which is a constant and could be added with other constants, any other number in the problem, plus 7x squared. So we do see we have x squareds here and here. They do not have to be next to each other. If they're in the problem and everything's kind of being added or subtracted in a long string, we can add those together. So if I have 10x squareds here plus 7 more x squareds here, that gives me a total of 17. 10 plus 7 is 17 x squareds. Okay, notice that what you're adding together doesn't change. Unlike multiplication, we stick with x squareds. How many of them? The coefficient is the only thing that gets added up and changed. Okay, and then we got to bring down the minus 5. There's no other constants to combine that with, but there it is, 17x squareds. When we add those two together, and then minus 5 as our final answer.